Finish.
Good. You can just give me a thumbs up.
I'm finished.
Awesome. Good. I see your thumbs ups. By the way, if you don't know how to do it on Zoom, if you click on participants, there's like little options at the bottom where you can put up different signs.
For me, it has a button that says reactions.
Or that too. That's the other way. But if you go to participants, you'll see there's a lot of different options. There's more options than just that. Okay. All right. Moving right along. So let me actually explain this part of it. So basically, these words sound very basic, right? Like a point, you guys know what a point looks like. You guys know what a line looks like. You guys know you might know what a plane is, maybe not. But what's important about these is notice that these are called undefined terms. So the reason they're called undefined terms is because all of them basically, like, if you think about a line, look what it says. It says it continues forever in both directions. So if I'm calling something a line, that means that it'll literally go forever and ever and ever and ever and ever, and it's never going to stop. That's going to be different. In the next slide, you're going to see a different thing, which to me, like in real life, if I talk about a line in real life, like, oh, there's a line on that piece of paper, or oh, there's a line on the board. Usually that line is kind of short. It stops on one side or it stops on the other side. So there's a difference between a line, what you might call a line in real life, and what you call a line in geometry class. So in geometry class, a line it's going to be going in both directions forever. Same thing with a plane. So a plane is kind of like if you think about a sheet of paper. A sheet of paper is flat, but a sheet of paper is not a plane because this sheet of paper stops at the edges, right? It's not going to go forever. But in geometry, a plane will go forever and ever in all of the directions until the end of time and earth and space. It'll literally never stop. Okay, so this is a plane that's just going to keep growing and growing forever. Now let's take a look at the other types of terms. So these are undefined terms because they never really end. And now we have defined terms. So these are three more definitions. But again, you do not need to copy down the diagrams or the ways to name the figure. And I just saw in the chat, but yeah, only write the words. Daniel gave me a thumbs up. Thumbs up from Tyrone. Thumbs up from Perla. Alejandro. Okay, we're finishing up. While we finish up, can somebody who maybe is done already maybe tell me why these are defined whereas the other ones were undefined? So what makes these line segment and array, what makes them defined? What do you think?
Wait, what does it mean by defined?
That's what I'm kind of asking you guys. I want you guys to try and guess why they might be called.
I think it's because these have endpoints.
So that's our key word, the endpoints. Okay, a line segment has two stopping points. Okay, so it as long as those two endpoints are there, that is it. It's not going anywhere else. Array has one stopping point and it goes forever in one direction, but it's going to stop when it gets to that endpoint. So that's the difference. An undefined term can be infinite, it can go on forever. But if it's a defined term, it has one place, at least one place where it's going to stop. So my next question is, where have we seen, are there any of these that we've seen before? So I'm talking about, have we seen point, line, plane, line segment, or ray in algebra?
Yes.
Yeah,
Ray.
which ones have we seen? I heard ray, for sure we've seen rays. What else have we seen?
Points.
Points.
Line
Exactly.
segments.
Line segments, maybe not as much. I was going to say line segment is the one that maybe we didn't see completely, because if I'm, and you do not need to write this down, but for example, in algebra, you might have a line that starts on the y-axis and then it goes like that. So this would be an example of what? What would this be? The one that I drew at the bottom, which we've all seen before in algebra.
Array.
Yeah. Yeah, this one's array because it has one endpoint. And then the other example that we've definitely seen in algebra is when it looked more like this and you had a line going, let's say like that. Now in algebra, I would always say, oh, that's a line, right? Why is this a line and not a line segment?
It goes on forever.
Exactly. It goes on forever. And that's the only difference. So line segment is the only one that we didn't really cover in algebra, but you've all seen all of these before. Okay. So now, what does this all mean? More definitions. I know there's I promise it's not going to be this much writing all the time. That's why I wanted to start today, because this is just, I want to get all of these definitions out of the way. So before we begin writing all of these down, I do want to read them out loud. So there's 1, 2, 3, 4, 5 sentences. Can I have 5 volunteers read each of the sentences?
Points that lie in the same plane are coplanar.
Coplanar. You pretty much got it. Coplanar.
Points that lie in the same line are coplanar.
There you go. All right. Next one.
Lines that lie in the same plane but do not intersect are parallel.
Good. Next one.
Points that lie on the same line are collinear.
Okay, so that's collinear, kind of like how we had linear functions. This is collinear. Next one. Next sentence.
Can I go again?
Mhm.
The segment addition postulate is a statement about collinear points.
Okay, lots of new words, right? So this one's the segment addition postulate, and you're gonna hear this word a lot in the future. So let's talk about what a postulate is. Can I have the next sentence? What is a postulate?
A postulate is a statement about collinear something.
Collinear, you got it. Read the next sentence though, because that one's going to tell us what the word postulate actually means.
A postulate is a statement that is accepted as true without proof.
Good. Okay, and then I'm going to read the last one. Like undefined terms, postulates are the building blocks of geometry. Okay, so that was a lot. So I know everybody's writing. I want everybody to pause so that you're listening to me. Okay, so with all of these words, the most important one right now for us is the word postulate. Okay, so like it said in the sentence, a postulate is like the building block of geometry, because in geometry, okay, when I think of geometry, I think of shapes, right? I think of squares and triangles and circles and things like that. There's a lot of rules that are actually a part of like how we understand those shapes. For example, a square has 4 sides. That is a rule, right? Or a square has all right angles. That is another rule. However, all of these rules have a special name, and that word is postulate. So if you see the word postulate come up, it's basically like a rule of geometry. It's telling you something that's true about that specific like concept. Okay. And I see everybody's still writing, so go ahead and finish writing. I know there's a lot.
I'm playing Queen while I wait.
Okay, as long as you turn it off when we're back. Okay. Who needs 1 more minute? Couple people? Okay. Okay. All right. So here is our postulate. Okay. So in this box, there's a postulate, which is, like I said, it's like a rule. And I'm going to read it out loud, and then we're going to break it down to kind of understand what all of it means. So as it says, let A, B, and C be collinear points. If B is between A and C, then AB plus BC equals AC. Okay, it's telling us a rule, right? Now let's actually figure out what it's saying. So can somebody remind me, what does it mean for these to be collinear points?
To wait, it's inside the line segment, right?
Yeah, exactly.
Yeah.
So they're all on the same line. So as you can see, A, B, and C, they're all located on the same line. If C was somewhere over here, out there, that would no longer be a collinear point because it's outside the line. Okay, so that's the first part. It's just telling us that these 3 points are on the same line. Then it says if B is between A and C, then AB plus CD equals AC. Okay, so that's telling me that AB, which is the line segment from A to B, plus BC, which is the line segment from B to C, equals AC. And AC is the line segment from A to C. And you might read that and you might be like, well, duh. Of course it does, obviously, right? So sometimes postulates are kind of like very, very basic, but it's still important to understand that these are rules for a reason, okay? They become very important later on. So I know this was a lot. Do I have any questions on any of the new definitions or on this postulate and what it's telling us? Okay. All right, so let's go ahead and do a couple of problems. So this is, now you can begin writing on the other side of your notebook. I know you wrote a lot of definitions. All right, so we're basically just gonna draw some of these types of lines, rays, line segments, all of these things. Starting with letter A, we're gonna draw 2 points, J and K, then draw a line through them. So I'm gonna just go ahead. For this part, I know you guys I see already people writing. You do not need to write everything because there's a lot of words on the page. I want you only write what I write with my pen. So don't write what's already there, write what I'm about to put on there. So I'm gonna draw 2 points. There's J, and I'll make K over here. And I'm gonna draw a line through them. So remember, the important thing when you're drawing a line is that it has to have arrows on both ends because the arrows tell me that this is going to be going on forever. And that was really not that straight. Try that again. There we go. Okay. So there's my line. So I'm going to label this. This is a line. And I'm going to give it a name. Okay, so when you name something in geometry, it's kind of like just if you're reading a sentence in a geometry textbook, it'll give you kind of like a shorthand way to write each of this thing. So instead of having to write the line JK, I'm going to draw, this is how I'm going to name it. Okay, so it says JK with a line on top. That's how I know that I'm talking about a line, because it has that line on the top of it. Now for example B, I'm going to draw 2 points J and K again. I'm going to put them in different places now. So there's J and there's K. This time, draw the line segment with endpoints J and K. So am I going to do arrows this time? Correct. Okay, no arrows. There's my line. It's super crooked. Let me do it again. There we go. This is no longer a line. This is now a line
Line segment.
segment. And with line segments, you do not need to put the line on top. So when I name this one, it's just going to be JK, just like that.
So we're only writing what you just wrote.
Exactly. Because there's a lot of words on this page. I don't want you guys to be stuck there writing words forever. Just write the important stuff. All right, and then next up we have, sorry, let me get, okay. Next up we have, very similar. Now I'm gonna draw a point K. So this is K. And I'm gonna draw a ray from the endpoint. So there's my ray. However, in order to name this ray, because I want to give it a name, I need another point on the line. The reason is if I just say, let's say, and pause writing, do not write the stuff I'm about to put in green. Let's say K has a bunch of rays coming out of it. It's like going in all directions. If I want to specifically talk about the black one, not the green ones, I have to have another point on the line that differentiates this one from the others. So if I put a point J, now I know that I'm talking about the ray that goes from K to J, and I'm not talking about all the other ones. So I'm going to erase those other ones so it's not confusing. And I'm gonna, this is my ray. And the name of this ray is KJ. Now, why is this one, why am I calling this one KJ and not JK?
Because
K is on the
the
left.
ray,
So it's kind of like when you're reading English or reading in general, you read from left to right, right? And here, the ray begins at K and goes towards J. So when I name this and when I put my little arrow on top, it's telling me the direction that the ray is going. It's not going from J to K, it's going from K to J. K is the endpoint.
Ms. Lopez, did the last one, did example B have a name? I didn't catch it.
Yes, I'll go back to it right now.
Thank
So
you.
what I explained with line segment is that it does not have a line on top of it.
Okay.
And actually, that leads me to this next point, which is that when you name a line or a line segment, since there's no direction, there's no specific direction, I could also name this KJ. And I could also name this one KJ because it doesn't matter the direction. What matters is when you have a ray, because rays go in one specific direction. Like this one. And as you finish copying, I'll go ahead and read the last example, example D. Now I'm going to draw 3 points, J, K, and M, so that they are not all on the same line. Then draw the plane that contains the 3 points. Okay, so for example, I have J, I have K, and I have M. Are these collinear points?
No.
Correct, they are not collinear because they do not belong on the same line. However, what I'm going to draw now is a plane. Remember, a plane is like a sheet of paper. And all 3 of those points are on the sheet of paper. They're on the same plane. So these lines, these points are not, they're not collinear. However, they are what's called coplanar. So they're not on the same line, but they are on the same plane. They're not on the same line, but they are on the same sheet of paper.
This is easier than algebra.
For now.
Yeah, for now.
To me, algebra was easier. I don't do well with shapes.
Algebra was hard. It was
Not
really
that
hard.
At the beginning, it wasn't hard. Like,
We all have different brains.
That's true. I think Perla's more analytical and maybe Tyrone, you're more visual. That sounds
And
about right.
what am I?
You tell me, I don't know.
I don't really know
You're
as
a
well. I don't know
person.
myself. That's actually very accurate, Tyrone.
You're a
The
person.
most accurate there is.
Okay, let's begin.
All right, so any questions on lines, line segments, rays, or planes? Oh, I didn't put the name of the plane, hold on. Okay, so with a plane, because a plane could have like a million different little points on it, so we're not gonna name it the same way that we did before, but what I'm gonna put is a little B on the corner, just like that. And this plane, we're just calling it B. That's it.
J, M, and K on top of B.
Okay. Questions, comments, concerns?
No?
No?
Geometry is cool.
I agree. I like geometry better than algebra, no, not gonna lie. Okay. All right, now, moving on. This is a fun time.
Do we switch to another page in our notebook?
You can, yeah. Well, if you're running out of room, for sure. I just mean anytime you have a new definition, you put it on the left. Anytime you have a new problem to solve, you put it on the right.
All right.
Okay. So raise of hands / just let me know if you've ever seen the Pythagorean theorem before. Because I know you guys, technically you learned this in 7th grade, regular math. So you guys skipped that. So I just want to see if anybody has heard of this before. Okay, no. Samaj has. Okay, cool. So it's very simple. It has a very long, confusing name, but I promise it's very simple. So the Pythagorean theorem is used to find the side length of a right triangle. Okay, so let's break that up. What is a right triangle? If you were looking at these pictures, what tells you that it's a right triangle?
it has
Because it has a 90-degree angle in a
90
square.
All right, so
Hey, how do 91-degree angles make you feel?
Very uncomfortable. We're not going to talk about those. Okay. No, 90-degree angles have a right angle, just like this one, just like all of the examples here. So if you see a triangle and it has that symbol in the corner, it's telling you that it's a 90-degree angle. And any triangle in the world that has a 90-degree angle, you can use the Pythagorean theorem to find the length of one of the sides. So let's go ahead and take a look at what this means. So like I have here, if I have this triangle with, it has an A, a B, and a C, we're always going to label the longest side. So which one's the longest side on this triangle?
Wait, C.
C, exactly. This side right here, C, notice that it is kind of like on the opposite side of the right angle. That one has a special name. We're going to write it down. It's another long name. I know in geometry, they love to use confusing names and make it seem really scary, but I promise you it's not. So this side right here is called the hypotenuse. And I hope I'm spelling this right. Hypotenuse.
You have to draw this?
Yes, ma'am.
Okay.
So the hypotenuse is the side that is opposite of the right angle. So far, so good? Give me a little nod if you, okay. So far, so good, cool. All right, so you're doing your math, you come to a problem and you see a right triangle. First thing you wanna do is identify the hypotenuse. Then we're gonna use the Pythagorean theorem, which is this equation right here. Okay, that equation is going to help us to solve and figure out the length of the missing side. So let's see what that means. So I've got two examples here. I want you to take a moment and just draw these triangles and label them with those numbers.
Ms. Lopez, you said the
Hypotenuse.
I'm gonna just call it hippopotamus. The
Uh-huh.
hippopotamus is the opposite side of where the right side is, like the 90-degree angle, right?
Correct. Mm-hmm.
Okay.
Usually, and you can also say it's the longest side, but sometimes it's hard to tell. So if you just remember it's opposite of the right angle, then you'll always be able to find it. So as you're copying, you might notice that in my examples, which side am I missing the length of? Which side is blank? What's it called?
The hypotenuse.
Yes, ma'am. Lovely. The hypotenuse. Okay, so yes, in example number 1 and example number 2, the hypotenuse is missing. We don't know how long it is. So that's where the Pythagorean theorem comes in. So I'm going to begin by, I'm going to label my sides using the same letters that we have in the equation. So I know that my hypotenuse is going to be C. Okay, the hypotenuse is always C. And then the other two sides, which are called the legs, don't matter. It doesn't matter which one is A and it doesn't matter which one is B. So for now, I'm going to say 8 is my B and 4 is my A. So I've got my A, my B, and my C. And then I'm going to plug those into the equation, which I'm going to rewrite. So my equation is A squared plus B squared equals C squared. That's my, this is the Pythagorean theorem right now.
A squared plus B squared.
So if I'm talking about the Pythagorean theorem, I'm talking about this equation. So I'm going to plug those in. So I know A is 4. So that's 4 squared plus 8 squared equals, and then I don't know what C is, right? So I'm just going to keep it as C squared. And now we're back to algebra, aren't we? So now we can solve this using our math. So what's 4 squared?
16.
16.
Oh God.
8 squared?
64.
64. I still don't know what C squared is, so I'm going to leave it. Now I add 16 plus 64 gives me
80.
80. Did I hear that?
Yeah.
Yes.
Good. And now I'm trying to get C by itself, but what's in the way?
Exponent.
Exponent.
So who remembers, if you have an exponent, what is
Square root.
the inverse operation? The opposite of exponent is to take the square root.
Let me take out my type.
And now that you guys have your nice calculators that I asked you to have, go ahead and find out what is the square root of 80.
Oh God, let me get my upstairs.
You gotta go upstairs?
It's
Okay.
8.94427.191.
Okay, so we're gonna round to the nearest hundredth. So that's gonna be 8.94, you said? Okay.
Ms. Lopez, I have a question.
Go ahead.
Was this supposed to go on the definition side or the note side?
Good question. Technically this, because it's an example now that we're working on, this should be on the notes side.
I put it on the definition, but oh well.
That's okay. Okay, so at this time, I want to know if you have any questions. That way you can do the next one on your own.
So you say class is over.
On
No.
our own.
On your own.
Can you say how you got that answer because it cut off?
Oh, of course, yeah. So the last step over here where I have to do the square root, so I got 80 equals C squared. The opposite of going to the second power is taking the square root. So in order to get rid of that exponent, I had to take the square root of both sides. So when I take the square root of 80, that's where Perla pulled out her handy dandy calculator and she got 8.94.
Okay.
So I want you guys now to go ahead and do number 2 on your own. Take 2 minutes, same idea, and see what you get. I'll meet you back here in 2 minutes.
Ms. Lopez, is there a song that we can use to memorize this formula?
Oh, you don't need a song for this one. This one's so easy.
No, it's not.
You got A squared, B squared, and that equals C squared. I don't know. Come up with one. Janelle's, yeah, you can, the 3 and the 7, either one can be the A or the B. It doesn't matter. The only one that always has to be C is the hypotenuse. All right, finish it up, 10 seconds. Okay. All right, what am I plugging in for A and B?
You're going to, oh wait, no, I'm not doing this. No.
3 and 7.
Good. So 3
What she
squared.
said.
You're so shy, Tyrone.
No, he's not.
No, I'm
He's
not.
too shy when
It's
it
just-
comes to sharing the information. He loves to read.
Oh yeah, there.
All right, so I
Yeah,
got
very
3
popular.
squared plus 7 squared equals C squared. And now I go ahead and do the math. So 3 squared is
9,
9, 7 squared is
49.
49. And all of
Paula,
that
how'd you
equals C
get
squared.
3 and 7?
58.
How did I get 3 and 7? So remember, I can label my triangle. The hypotenuse is always the longest side, or if you think about it as the one across the street from the right angle. So this is my hypotenuse, that's C. And then the other two, the 3 and the 7, it doesn't matter which one's which. So you could say that 3 is A, and then 7 is B. But it could be, you could have done it the other way and it doesn't matter. Okay, so now 9 plus 49.
9 plus 49. Hold up, I want to do this.
58.
Everybody be quiet. Oh my God.
Too slow.
You guys are so mean.
Let
58.
Tyrone shine.
58 equals C squared. He was too slow.
I shouldn't have said geometry is easy.
And my final step, in order to get C by itself, I need to take the
Oh no.
Y'all better answer that question.
square root.
Jalen, shut up.
All right, and my square root of 58 is
Wait, I need a calculator.
7.62 when it's rounded.
7.62. Awesome.
Paula, go to college.
No, I'm not smart enough.
Yes, you
So
are.
now what I
No.
can do is I can go ahead and label my sides on back on the triangle. So in number 1, it was 8.94. And for number 2, it was 7.62. And notice that it is in fact the longest side, right? In example number 1, I have 4 and then 8.94. So 8.94 is my longest side. In example number 2, 7.62 is the longest side. So these are all the lengths. And it doesn't say the units in this scenario, but usually it'll say like in inches or feet or whatever. Questions? Big words.
Geometry is hard.
Big words, but it's really not harder than anything you guys have done in the past. Okay, now we're gonna kick it up a notch because y'all know I love to do that. Don't worry, I see, I see the looks
You're
of confusion.
tricking us.
Do not worry, okay, y'all. This is why Miss Lopez is the best. I will make this make sense. Okay. The only thing I want you to write down in your definitions is the stuff I'm highlighting right now. Y'all ready? So write down that, and then write down just this right here.
Okay. Is there a song for that formula?
Unfortunately, no, but I'm thinking of composing one because this one is a little more complicated.
A rap song.
I'm gonna win
What are you gonna win?
in another Uber Eats.
Okay. I just said an idea. I'm not saying like they should actually make it, Jalen. I'm just giving ideas.
Just putting it out there.
Yeah, like. But what if that rap song helps you memorize it, Jalen? Don't
This is
be
a
ungrateful.
definition, right? This is a definition.
Yes, sir. Yes, good question.
You stop.
Done.
You guys may call me rude, but hearing my baby sister just crying just makes me laugh.
Okay, that's just weird. That's just straight up.
No. Before you say
You're evil.
I'm gonna. It's that she overdoes it. Like it's
Oh.
like, why? Why did this happen?
Is this
Why
off
can't I
topic?
get my way?
Yes, this is definitely off topic, but I also
Ms.
understand.
Okay, save it for the end.
Okay.
Wait.
Okay.
You're trying to learn.
Okay, I heard my name.
Gosh, I'm trying to ask a question.
Go
Be
ahead.
respectful of your classmates. Okay. The x1 and the x2 are not exponents, right? They're just saying like x1 and x2 because there's
Yeah,
2 points on the x.
Correct. Yeah, so those
Okay.
are not called exponents. That's a good question. Those are called subscript, but that doesn't really matter right now.
Uh-huh.
It just helps you differentiate
Okay.
one point from the other.
I'm gonna call them
There's
subtitles.
like a name for every small thing.
That is
Like,
true.
oh,
Obviously, you're not just gonna call them numbers.
I just thought they were explaining X1 and Y2 or whatever. I didn't know that they had a name.
Also, Ms. Lopez, why are they like? Oh, never mind.
Okay, I see most people are almost done. Does anyone need another second? Okay. All right, so why do I even bother explaining this distance formula? Let me explain why. In the previous problem, we had a nice little diagram, right? It was just a triangle on a page and it was labeled nicely for us. However, this is like regular 7th grade math. We are geometry students, so we're gonna make things a little harder. Instead of a triangle nicely on a page like this with all the nice labels and all the nice numbers, the way you're gonna see this is on a coordinate plane. So take a look at what's going on here. So I have this triangle. You do not need to copy it down. I just want you guys to watch for now. So can I see eyes on screens? Okay. So I have a line segment, and that line segment is UV. So I'm going to highlight just that line. And I want to know the distance. How long is UV? Well, there's no numbers, are there? So I can't know just by looking. And this line is unfortunately going, it's kind of diagonal, so I can't count the boxes either. So I have no idea how long this line is. However, I can use the Pythagorean theorem to figure it out. So again, look at me, not at the, don't be trying to write down this entire diagram because it's going to be a waste of time. I would prefer if you just look at the screen. Anytime you have a line segment like this one, it's diagonal, it's not going straight up and down or straight side to side. What you can do is you can make it into a triangle. So that's what they did here. They drew these dotted lines. I'm just going to connect them. And you can turn it into a triangle. When you do that, you're going to be able to count the units of how long is the bottom line segment and how long is the line segment on the right side. So go ahead and look, just looking at your screen, how long is this bottom line segment?
The one in black,
Yeah, on the bottom.
it's
It's
6.
1.6 units, 6, whatever.
I think it's 6.
6 units, yeah. Okay, what
Yay.
about the one on the right side, the one going straight up and down?
5.
Also 6 unit. Wait, no, 5 units.
5 units. Okay. So with this information, now I can use the Pythagorean theorem to figure out how long is the purple side. So this is what the instructions are saying. It's saying find the length of the line segment UV first by using the Pythagorean theorem and then by using the distance formula. So the distance formula looks super complicated, but in a minute you guys are going to see that it's essentially the same exact thing. What we're going to start by doing is the Pythagorean theorem. So let me do that in green. And this is what you can write down. Okay, so my Pythagorean theorem is a squared plus b squared equals c squared. Which ones are my a and my b? Which of these sides are the a and the b?
5.
6 and 5, exactly. So I'm going to go ahead. Does it matter which one's which?
No.
It does
Nope.
not. Okay, so I can do 5 squared plus 6 squared equals c squared, which we still don't know. We just did all of this, so I'm going to run through it real quick. 5 squared is 25. 6 squared is 36. Equals c squared. And now it's 25 plus 36.
It's not in.
It's 61.
61. Equals c squared. And in order to get my final answer, I always need to take the square root at the end. And the square root of 61 is
7.81.
7.81. There you go. So now I know that this is 7.81 units. Questions on that? That was just Pythagorean theorem all over again. We haven't used the distance formula yet.
No.
Okay, cool. All right, so now I'm going to do the same exact thing, but I'm going to use the distance formula. So let me see. I want to see if I can copy this page again. I don't think I can, though. Hold on. I can. This is awesome. Yeah, okay, cool. I just pasted the same. Okay, so I'm gonna erase this so that I can do it the other way. But if anyone needs me to go back, I can still go back because I copied and pasted it.
Okay, good.
So there's what we just did. Here's my new page. Okay. I'm gonna erase, erase, erase. All right. So here's where the distance formula comes in. The first thing I'm gonna do is I'm gonna label my points. So for you, that's gonna be, who wants to help me label that?
Me. Wait,
Okay.
how do I label it?
The coordinate point.
Oh. I always end up saying me to things I don't know how to do.
Okay.
How do I put myself in these situations?
It's okay, let someone else help you out.
Ms. Lopez, what was the question again? Sorry.
It's okay. We're gonna label the point U and the point V, starting with U. Label the coordinate point.
Okay, it is 3 comma negative. I mean -3 comma -1.
Good. -3 comma -1, and then V.
I want to do it.
Go ahead.
It's okay. So we'll go negative. Wait, no, 3,
Mm-hmm.
comma 4.
Yeah, you got it.
Yay.
3 comma 4. Okay. Now I have my 2 points. I can plug those points into the distance formula. The distance formula, which I highlighted up there. This is kind of like, do you guys remember this? Do not write this down, but do you remember this? Y2 minus Y1 over X2 minus X1.
Yes, I do. Yes, I do.
Okay, good. So this is very, very similar. All we're gonna do is we're gonna call, let's say U is number 1. So this is gonna be X1, Y1. And this one is X2, Y2. It does not matter which one is 1 and which one is 2, but I just decided to make one, U is going to be my X1, Y1, and V is going to be my X2, Y2. And I'm going to plug those numbers into my distance formula. So I'm going to rewrite my distance formula. Okay, and this part, if you haven't been writing this part, do write this down, the actual math. And let's just go right through and plug everything in. So what is my X2? Oops. Just based on what I wrote down in my graph.
It is x2,
Mm-hmm.
3,
3, X1,
-3.
negative 3. And then Y2
Is 4 and -1.
4, and negative 1.
Okay, I understand this.
Good.
My brain is expanding.
Big brain.
Yes.
All right, the next step is I'm just going to simplify. So inside of my parentheses, I have 3 minus -3. What's 3 minus -3?
6.
6, good, because the 2 negatives make a positive. So what I'm doing here is really 3 plus 3. That gives me 6. And then here, same thing, 4 minus -1 gives me
5.
5. Good, Daniel.
That's right.
Okay, continuing past that point, I'm going to do my exponents. So I have 6 squared, which is 36. And I have 5 squared, which is 25. Now I'm going to add. 36 plus 25 is
61.
61. And the square root of 61?
15.25.
15.25. Square root of 61 should be a little lower than that. Just check your calculator again.
7.81.
7.81, there you go. And there's our answer. Now, we got the same answer as before, but did anyone else notice anything similar before we even got to the final answer?
It was similar to the previous equation.
Yeah, here. So let's take a look at what we did before. Before we did 5 5 squared plus 6 squared. We got 25 plus 36. Then we took the square root of that, and we got 7.81.
Oh,
And what did we do here? We had a similar idea. We had 5 squared plus 6 squared. We got 25 plus 36. That gave us 61, and we took the square root of that. So I'm going to flip back one more time. Take a look at all of the similarities. All of these similarities. First, I did 5 squared plus 6 squared. I did that here as well. It just looks different. I have 5 squared plus 6 squared. I did 25 plus 36. That's the same thing over here. I have 25 plus 36. I have the square root of 61. I have the square root of 61. And then I got the same answer for both of them. So basically what this is showing you is that the distance formula is really the same thing as the Pythagorean theorem. It's just that they wrote it all down in one step, rather than the way the Pythagorean theorem breaks it up into A, B, and C. The distance formula kind of puts it all in one, and you have to do it. It kind of makes it look a little more confusing, but at the end of the day, it's giving you the same exact steps. So you have to memorize the distance formula. I'm not saying you shouldn't memorize it, because if this comes up on a test, you have to know what it is. However, if it's easier for you to do it like the Pythagorean theorem, then you're more than welcome to do it like the Pythagorean theorem instead. If you're more visual, like I know Tyrone said he's more visual, it's probably going to be easier for you to make your triangle, label it, and then use the Pythagorean theorem. But if you're more analytic and you prefer algebra, then it might be easier for you to just use the distance formula and plug everything in. Any questions?
No.
All right, give me a quick thumbs up, thumbs to the side, thumbs down on how we feel about what we've learned so far. Thumbs up, side. I see ups and sides, not so many downs. Tyrone, you just changed your mind. You had it to the side before. Okay, there we go. Okay, good. All right. So kind of working on it. Trust me, these things will just get easier and easier the more you do it. So here's an example where we're going to do it again. Can I have a volunteer read the question? Just read the question.
Me.
I
Me.
see Daniel raising his hand nice and politely. Let's have Daniel read it.
Dang it.
Determine whether JK and LM have the same length. Justify your answer.
Cool. So now we're looking at two different ones. We're looking at JK. I'm going to label them. I'm going to make them nice and colorful. So that, again, you do not need to copy the diagram because that's too much work. Just copy the question and whatever math you write down. So I have JK. And I have LM. I'm going to make that one green. And it's asking you which one is, if they're the same length or if they're different, which means you have to figure out what is the length, right? So you can do it using the distance formula, or you can do it using the Pythagorean theorem, whichever one you are more comfortable with. However, you do have to memorize this formula. Even if you don't use it all the time, you have to memorize what it looks like. So do not forget to memorize. Okay. Take this one. I'm going to make this one a little longer because it is getting a little harder now. I'm going to give you guys 7 minutes. That's a lot of time, 7 minutes. And I want you to find the length of JK, find the length of LM, and then see if they are the same or if one is longer than the other. Go ahead.
So we're just trying to see if they're the both the same length. That's all.
You are, but you have to figure out what is the length first. So find the length and then find out if they're the same or not. Also, Cosmo says hello.
Hello, Cosmo. I got my answer.
Cool. Good. You went fast.
I just got an alert.
Yeah, me too.
Same.
Who just joined?
Eric was, or not Eric, sorry. Jalen was gone and then he came back. I don't know why. Cosmo likes playing with my pen and he keeps jumping up on the desk to play with it. But you can't, sir. I'm using it.
Ms. Lopez, one day you should dress Cosmo as Cosmo from the Fairly Godparent.
I know.
Yes.
How is how is she gonna be able to do that?
He,
Just get
ha-
him a costume. or
he
something.
hates being in any type. I've tried even putting a collar on him and he hates it. So I don't know how that's going to go down.
He's not a dog.
He's not
Just
a dog.
for the pictures. it's
Just for the gram.
Yeah,
Just bit me. Okay.
I lost my food.
How much time are we have left? We have 2 minutes left.
2 minutes.
I go first.
2
I'm
hours.
feeling confident.
Do you guys need that time? I don't know. You tell me.
I need more time, Miss.
Okay. Well, you have 2 minutes.
What? Miss, I'm getting just one number. That's the length?
Yeah.
Okay. I don't know if I'm doing this right, but I hope
It's
I
okay. At
am.
least you're trying. That's the whole point. Even if you're doing it completely wrong, you tried it. And then you'll learn from your mistake.
Um,
Oh my God. Cosmo.
Ms. Lopez, I had seen that you, in one example, you put like the little line on top with an arrow.
Mhm.
That's not a different, right?
That
Wait,
one
that
is,
means a
That's Ray.
They're not the same.
Oh,
Yeah.
okay. Thank
Mhm.
you for the clarification.
You're very
Can I
welcome.
go first? I'm feeling confident.
You're feeling confident? Okay, you got one more minute and then
Yes.
you can go. So
Those
just so
words
you
are gonna bite me.
Ms. Lopez, we read it from left to right, right?
Mm-hmm.
Okay.
Okay, 10 seconds remaining. And time. Okay, so the question is, are they the same or is one longer than the other? And before we go over how to find the answer, I just want to hear what you guys think. So Tyrone, you said you wanted to say?
Yeah. Okay, so what's the question again?
Are they the same length?
Yes.
Yes, okay. Does anybody agree and does anybody disagree?
No.
Daniel
I'm not-
disagrees. Okay. Does anybody else agree / disagree? Not sure? No one feels confident? Okay, let's go through it together. So remember, there's two ways to figure out the length. One is to use the Pythagorean theorem. The other is to use the distance formula. So I'm going to do, for the purple line, I'll use the Pythagorean theorem, and for the green line, I'll use the distance formula. That way we get to practice both. So starting with JK, we're going to find the length of JK using the Pythagorean theorem. So in order to use the Pythagorean theorem, what do I need to do? What do I need to turn this line into? What should I turn this line into in order to use the Pythagorean theorem?
Uh.
Yes.
Triangle.
To be completely honest, I have no idea. Oh wait,
You turn it to like a right triangle or something.
Yeah, Tyrone's got
I
it.
completely guessed that. Yay.
Okay, so you're
Tyrone
gonna,
is on roll today.
yeah, he really is. You're gonna turn it into a right triangle. My screen has frozen for some reason, so just give me a moment. I'm gonna
Wait, I can annotate.
hold on.
That's tough. It be like that sometimes.
There we go.
It's blank.
Okay, there we go.
Oh, there we go.
So yeah, so I'm gonna turn it into a right triangle because that's how you use the Pythagorean theorem. So I'm gonna go straight down and then straight to the right. And then what do I need to find? What do I need to look at? Hmm?
Wait, what was the question?
The X and the Y.
Okay, so I drew my triangle and now I'm gonna use the Pythagorean theorem. So I need to label, Perla said the X and the Y, but in this case, yeah, it's a triangle. So we're gonna label the sides. So what is?
Okay.
So what are those lengths gonna be? What's the length of the side on the left side? 3, good. That's 3, and then the bottom one is 2. Beautiful, okay. Now I can use my Pythagorean theorem. So I know that the Pythagorean theorem is a squared plus b squared equals c squared. I plug everything in. So I have 3 squared plus 2 squared equals c squared. With me so far? Okay. Now 3 squared is 9. 2 squared is 4. 9 plus 4 is 13. What do I do to both sides to get my final answer?
You like
You divide
you
the
like count them and
Mathematically, what am I doing in this last step?
forgot what it's called.
You forgot what it's called.
awkward moment.
What's it called? I
Give
see
me a hint.
I see someone using their hands to draw it in the air. What's the word though?
Wait,
Can I have a hint, please? What's the first letter?
Miss
Yeah, what?
Square.
The
Square.
square root.
Oh
We're
my
taking the
gosh.
square root. Okay, so that's going to give me the value of c. What's the square root of 13? Use your calculators.
Wait, how do you input the square root thing again?
Look for the button. There's a button that looks like that square root button. You should, I don't know which calculator you're using, so you have to look for it.
Okay.
And what you get? I can kind of see it. 3.605, right? So I'm
I still can't find the button.
gonna keep this as 3.6. Which calculator do you have, Tyrone? Let me see.
This one.
Oh, it's a school one.
3.60551275.
Yeah, I'm gonna simplify it to just 3.6. So Tyrone, put it up to the screen really close so I can tell you which button it is. Okay, go up a little bit. There. Do you see right to the left of the division symbol?
To the left. Oh, okay, thank you.
You're welcome. Okay, so that was the Pythagorean theorem for JK. Now we need to find the length of LM and see if it's the same or not. But instead of the Pythagorean theorem, I'm going to use the distance formula. So I'm going to begin just by writing my distance formula down. The square root of x2 minus x1 squared plus y2 minus y1 squared.
Wait, what time does this class end again?
2:30. Oh, technically it ends now, doesn't it?
Oh,
Okay, let's finish this
Dang it.
problem and then we're done. My bad, I didn't keep an eye on the clock.
it's all right.
Okay, so in order to get my x2, x1, y2, y1, I need to label all of my points. So point L is -1, comma -1, 2, 3, 4. And point M is 2, comma -2. Agree? Look good? Okay. I'm gonna take that as a yes. Okay, now I'm gonna plug everything into my formula. So x2 is -2. Sorry, no, +2. So I've got 2, and then x1 is -1. So I have 2 minus -1 squared. And then I have my y2 is -2. And my y1 is -4. So -2 minus -4 squared. Now I have to simplify everything. So I have 2 minus -1. That's 2 plus 1. What's 2 plus 1?
3.
3. So I have 3 squared. And then this one's super confusing. I have -2 minus -4. So that's really -2 plus 4.
Which is, hold up, I think I have this. Okay, 2, no. Would that be just 2?
That would be just 2. Exactly.
Yay.
All right, so I've got 3 squared and 2 squared. So that's 9 plus 4.
I remember the chart you made. A negative plus a negative equals a positive, and a positive plus a positive equals a negative.
Yeah.
And then,
All that.
Yeah.
All right, let's finish this up. So then 9 plus 4 is
Tyrone said positive plus positive equals negative.
he's just spitting
Oh.
lies. All right, 9 plus 4 gave me 13, and then we already did this. We already know that the square root of 13 is 3.6. So, are they the same? Are they different?
The same.
The same.
You
All
see,
right.
me and Tyrone are so smart.
Yes, very intelligent,
Yay.
very intelligent. 2 different ways of doing the same thing. One is more visual, one is more mathematical. Up to you which one you use, but you must memorize the formula either way, because this might come up on a test and you have to know what it looks like in order to get the correct answer. Any final questions? This is all for today. Any final questions?
No.
No. Cool. I'm not going to give you homework today, but I am going to assign homework tomorrow through Khan Academy, but I'm going to show you tomorrow how to join because it's going to be a new code, a new everything. So tomorrow,
Not Khan.
I know you love your Khan, Daniel.
No, I like
I'll-
the game.
We're doing Khan
That's
Academy.
Khan.
For now, yes, I will give you the information tomorrow. I will not assign homework today, but I will assign homework tomorrow. And this class was recorded, so I will be posting all of the class recordings like last year. And if you ever want to watch it to review anything, you can watch it. All right.